Oh my! Static equilibrium?
Newton's first law.
And I think we need help again. Let's call Scotty Scholars HQ.
Isaac Newton was an English mathematician, astronomer, and physicist who is widely recognized as one of the most influential scientists of all time and a key figure in the scientific revolution. Newton's laws of motion are three physical laws that, together, lay the foundation for classical mechanics. They describe the relationship between a body and the forces acting upon it, and its motion in response to those forces. The first law of motion, or the law of inertia, says that an object stays at rest unless a force is acted upon it. For example, see this water gallon? It is just standing still on the ground. It did not move at all. Hence, this gallon is at rest. Let me state again the first law of motion. So it was said that if there is no acting force upon the object, then it is at rest. When all the forces that act upon an object are balanced, then their object is said to be in a state of equilibrium. The forces are considered to be balanced if the rightward forces are balanced by the leftward forces and the upward forces are balanced by the downward forces. Consider the box pictured in the force diagram shown below. Note that the box is at equilibrium because the forces that act upon it are balanced. However, the individual forces are not equal to each other. If an object is at equilibrium, then the forces are balanced. Balance is a key word that is used to describe equilibrium situations. An object at equilibrium is either at rest or staying at rest, or in motion and continuing in motion with the same speed and direction. Suppose the tension in both arms of Mark is measured to be 75 newtons and that the angle that each cable makes with the horizontal is known to be 47 degrees. What is the weight of Mark? This question can be answered by conducting a force analysis using trigonometric functions. But before that, the first thing we need to do is to draw a free body diagram. These first two arrows represent the tension, while the arrow downwards represent the weight. So this is now your free body diagram. Notice that this free body diagram is in an x and y plane. This is vector A, while this is vector B, and this is vector C. The x component of the A vector and the B vector should be equal to 0 when we add. Let us find x first. So x is equal to A cosine 47 minus B cosine 47 equal to 0. As I said before, the sideward forces should be equal to 0 since Mark is not moving, thus at state in equilibrium. Next, we should find the y. Sine 47 is equal to y divided by 75 newtons. Y then is equal to 75 newtons times sine 47. Then the answer for y would be 55 newtons. Since each of Mark's arm pulls upward with the same force of 75 newtons, then the total upward pull of himself is 110 newtons. Therefore, the force of gravity, or also known as weight, is 55 newtons down. All in all, Mark weighs 110 newtons. Since equilibrium also talks about forces, we should not mistake mass and weight. The weight we are talking about here is a gravitational force, or the force of gravity that exists. The net force is a vector sum of all the forces that act upon an object. That is to say, the net force is the sum of all forces, taking into account the fact that a force is a vector and two forces of equal magnitude and opposite direction will cancel each other out. Observe these examples. The first one has the same direction and the same magnitude, thus we add it. The second one, however, has different magnitude and direction, that's why we subtracted it. But if both forces have the opposite direction but the same magnitude, they will cancel or balance each other out. For example, this cup. This cup is in a state of equilibrium. Therefore, all forces are balanced out. Suppose this box has a friction force of 5 newtons, an applied force of 5 newtons, a force of gravity of 10 newtons, and with a force of air resistance of 35 newtons. What is its net force? So here is a diagram of the problem mentioned a while ago. Net forces are about summing up all the forces together. It was also said that two forces of equal magnitude and opposite direction will cancel each other out as they are balanced. So in this situation, the leftward and rightward forces are cancelled out since they have equal magnitude and opposite direction. However, the upward and downward forces aren't balanced at all, so what we're going to do is to subtract it because they aren't equal. The net force is 15 newtons up. The upward force of air resistance is only partially balanced by the downward force of gravity. Let's have a sneak peek of projectile motion. A projectile is an object upon which the only force acting is gravity. In a projectile motion, there are two things you should also consider: the horizontal displacement and the vertical displacement.